Alright, this is a continuation of the practice. Found a mistake. It was just silly of me. Right here in a quadratic formula, 4 times a times c. Well, minus 4 times a times c. I went b times c because I'm not that bright. Alright, so a times c, 1 times 25 is just that, 25. Alright, so let me just do this now on a separate piece here where I got this correct. I've got x is equal to negative 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 25 is 100. Not that crazy, 600. I was wondering why they're making this problem so tough. So what have I got here? Negative 6 plus or minus the square root of 36 minus 100 is negative 64. All of this divided by 2. I'm going to express this as negative 6 plus or minus the square root of negative 1 times the square root of 64 divided by 2. Negative 6 plus or minus square root of negative 1 is the letter I. Square root of 64 is 8. All this divided by 2. So if I factor out a 2 out of the numerator, I get a negative 3 plus or minus 4i divided by 2. The 2's would cancel out, so there it is, negative 3 plus or minus 4i. And going back to number 19, and we've got letter C here. Alright, negative 3 plus 4i, negative 3 minus 4i, negative 3 minus 4i, negative 3 plus 4i. Sorry about that, but obviously a times c, use the right value for a, don't use b. I was wondering why that number was getting so large, and they're making that problem so tough. Maybe not for you, but obviously too tough for me. Alright, that solves that. A times c, not b times c. Alright, so what do we got now? Picking it up with number 20. Absolute value inequality. The absolute value of x plus 16 is less than 14. These are the easier of the two. The less thans are easier than the greater thans. So what I'm going to do is use the negative here, the negative of 14, less than x plus 16. I'm dropping the absolute values, less than 14. So what I did here was, this is a less than, this is 14. All I did was to keep this in the same direction, less than. I used the negative on the left and I used the positive of 14 on the right. And now I'm just going to solve this by subtracting 16 3 places. Negative 14, negative 16 is a negative 30. Less than, the 16's cancel out x, which in turn is less than 14 minus 16. Signs are unlike. Find the difference if it is 2 and it's negative. So between negative 30 and minus 2, number 20, letter B. Letter B. Alright, so the less thans are easier than the greater thans. Alright, keep everything in the same direction, less than and less than, the negative on the left and the positive on the right. Okay. Number 21, we haven't really seen one like this, and the reason you've seen a couple of examples that we didn't necessarily cover is that this practice is a departmental practice exam, so there'll be a couple here that we didn't necessarily cover, but I'm going to do this one anyways. The best way to handle this is to actually graph this and find out where the graph of this is greater than 0, above the x-axis. If you were to graph this, x squared minus 9 greater than or greater than 0, it would look something like this, where this is minus 3, this is positive 3, and this is negative 9 down here. The vertex would be at 0, 9. When you graph it, it would look like this. So where is this equation? Where is this parabola greater than 0? Where is the parabola above the x-axis? Well, everything to the left of negative 3 and everything to the right of positive 3. So number 21, right here. everything to the left of -3. All right, it's above the x-axis, and everything to the right of +3. Letter B. That's what the graph looks like. Here again, you know, we've seen inequalities, linear inequalities. We've seen absolute value inequalities. This is the first time we've seen a quadratic inequality. Will you see one like this on a test? The answer is no, but I wanted to show it to you. And here again, this is a departmental final, so there's some examples that we didn't necessarily have the opportunity to cover, but no big deal. All right, which of the following is an odd function? Well, an odd function is symmetric to the origin. All right. Now, one way of doing this is if I were to rotate this 180 degrees, this graph would look just like the initial one. Same thing for this one and same thing for that. This guy here is obviously symmetric to the y-axis. It's an even function. All right, this is odd because I've got these 2 points that are mirror images of one another. Let's say 1 positive 1 1 is a mirror image of -1 -1, and here again -1 1 and +1 1. These are mirror images. But you can see this guy here is symmetric to the y-axis. It's an even function. And what he's asking me is which one is not odd. Well, if this is even, it's obviously not odd. Let us see. All right. And here again, now he's asking me, you know, which one of these graphs represents the equation that he's given me. Now, what I like about this, we know this, that the general equation of a circle looks like x minus h quantity squared plus y minus k quantity squared equal to the radius squared. All right, so after the minus sign comes your h value. After the minus comes your k value. After the minus sign, I see a 4. After the minus sign, I see a 1. All right, it's great. If these were pluses, I'd have to change the signs, but it's nice. After the minus sign comes your h. After the minus sign comes your k value. All right, so I'm looking for a circle that has a center at 4 1. First quadrant. Well, this is the only circle, number 23, that has the center in the first quadrant. There it is. 4 1, right here, letter A. And if you want to look at this, this is r squared, and if r squared is 16, then r is the square of 16 of 4. You can see the radius is 4, 1, 2, 3, 4. Letter A. Gotten awful dark. Let me see if I can lighten this up a little bit. It's a little bit too dark. Alright, it's a little better. Number 24, find, giving an equation, find f of -9. So my function, number 25, is f of x equal to the absolute value of x minus 6. He wants me to find f of -9. So the absolute value of -9 minus 6, the absolute value of -9 is 9. 9 minus 6 is 3. Number 24, letter C. Absolute value minus 9 is 9. 9 minus 6 is 3. All right. Number 25. He's asking me to find the sum of two functions. 25. He tells me that f of x is equal to 3 minus 4x. G of x equal to minus 9x plus 9. He's asking me to find f plus g. Alright, f plus g of x is the f function added with the g function. So it's 3 minus 4x added with minus 9x plus 4. Let's see, a minus and a minus is a minus 13, minus 13x. Positive 3 added with 4 is a positive 7. All right, adding the two functions, combining like terms. And what number is this? Number 25, and it's letter C. Minus 13, let me see. Minus 13x plus 7. Number 26. He's asking me to find f plus g of negative 1. The f function, f of x equal to 2 plus 5x. The g function, minus 3x plus 4. So he wants me to find f plus g of negative 1. So this is f of negative 1 plus g of negative 1. So what's f of negative 1? F of negative 1 is 2 plus 5 times x. X is negative 1. So this is 2 minus 5, which is a negative 3. So this guy is a negative 3. What's g of negative 1? Well, substituting in negative 1 here. Negative 3 times a negative 1 is 3 plus 4 more. That's going to be 7. So what I'm doing is I'm taking f of negative 1 through negative 3 added with g of negative 1 is 7. So I get a minus 3 plus 7, and that's simply going to translate to 4. Number 26, letter D. f of negative 1 plus g of negative 1. F of negative 1 was negative 3. G of negative 1. Negative 1 times 3 is negative 3 plus 4 more 7. Negative 3 plus 7 is a positive 4. Number 27, find f minus g. Well, they should have put as f minus g of x, but they didn't do that. 27, f of x equal to 4x minus 5. G of x equal to 2x minus 4. Alright, so we're going to find f minus g. They should have put the x there, but they didn't. So this is f of x minus the g of x function. Here's the f of x function, 4x minus 5 minus the g of x function. Notice I'm putting this in parentheses. This minus sign is going to apply to both the terms. So this is 4x minus 5, minus times a positive is a negative, but minus times a minus is a positive. Combining like terms, 4x minus 2x is 2x, minus 5 plus 4 more is a negative 1. 2x minus 1, letter C for number 27. There it is. 2x minus 1, 2x minus 1. All right, number 28. He wants me to multiply these functions now. He's asking me for f times g. What they should have put is an x here, but you get the idea. So much nicer when the problems are at the top. I got more room. F of x equal to 9x plus 8. G of x equal to 2x plus 6. Find the product of these two. Alright, so it's f times g of x, which translates to f of x times g of x. So I gotta FOIL this out. So I've got 9x plus 8 times 2x plus 6. Let's see, 9x times 2x is 18x squared. Up top here I've got 54x. In the middle I got 16 more x, and then my product of my last terms is a 48. So 18x squared plus, looks like 70x plus 48. And of course it's always a situation where you got to look at number 28. Looks like letter A. 18x squared plus 70x plus 48. Foiling. Letter A. There it is right there. Letter A. And there was some close, but not all that close. Foiling. How many times have we foiled? Number 29 is asking me for the quotient. Alright, the quotient of f over g. Alright, f over g of x. So it's the f of x divided by g of x. What's the f of x function? Well, it's 2x plus 3. And the g of x is 5x minus 2. Well, it can't be this guy, because that's the wrong numerator and denominator. It can't be him again. It looks like the same thing. Letters A and C are very similar. They both have the same fraction we do. Now, the difference is he's telling me that x can't be 2/5 here, and he's telling me x can't be negative 3/2. What we're concerned about is the denominator. The numerator can take on a value of 0. 0 divided by anything is 0, but the denominator cannot be 0. You can't divide by 0. So 5x minus 2 can't be 0. When does 5x minus 2 equal 0? It equals 0 when x is equal to 2/5. So I cannot use 2/5. If x was 2/5, this would be 2 subtract 2. This would equal 0. You can't have that. Alright, so x cannot be 2/5. That's why it's A and not letter C. You're not worried about the numerator, you're concerned with the denominator. The denominator cannot be 0, that's why x cannot be 2/5. This is saying something about the numerator. I don't care less about the numerator. It's the denominator that we're concerned about. Alright. Difference quotient. Number 30, f of x plus h minus f of x divided all of h. And my function here is f of x is equal to x squared plus 3x plus 1. I'm going to solve for this first. F of x plus h. F of x plus h. So wherever I see x here, I'm going to substitute x with x plus h. So this is x plus h quantity squared plus 3 times x plus h plus 1 minus f of x minus this guy. Well, if I'm going to subtract this guy, all the signs here are going to change. So I can save myself some effort. Minus f of x minus this guy. So the positive becomes a negative. Positive becomes a negative. The positive becomes a negative. And this is all divided through by h. Now in your notes, you've got what this guy looks like foiled. It's x squared plus 2xh plus h squared. Distributing the 3, I get 3x plus 3h plus 1 minus x squared minus 3x minus 1, all divided by h. I'll do that in a minute. But if I've done this properly, I should get some cancellation, a lot of cancellation. The x squares go away, a positive 3x and a minus 3x go away, a positive 1 and a negative 1 go away. So I'm left with 2xh plus h squared plus 3h, all just divided by h. And once again, if I've done this properly, I should have a common factor of h in the numerator. minus 2x plus h plus 3 divided by h. And finally, the h's cancel out. And number 30, letter B, and what do we got here? Oh, this is a positive. Thank you. Thank you, Mr. Gomes. That's a positive, and that's a positive. Okay. Can you read my own writing here? Alright. This was a positive 2xh. This is a positive. That's a positive. Alright, so factoring now the h out. 2x plus h plus 3. 2x plus h plus 3. Can you read my own writing here? Alright, this was a positive, not a negative. Alright. Here's the deal with radicals. We can't take the square root of something negative. We can take the square root of something that's equal to 0, but it can't be something negative, all right? Because if it's negative, it's going to be an imaginary number. We can't do that when we're talking about domains because we work with the real number system. All right, so we've got this situation where f of x is equal to the square root of 3 minus x. So what I'm saying to myself is that this guy, worst case scenario, could be 0, but it's going to be a positive value. So 3 minus x has to be bigger than or equal to 0, which means that minus x has to be bigger than or equal to, bringing this over as a negative, you get a minus 3. I could care less about minus x, so I'm going to multiply this whole thing through by a positive. If I do that, this becomes positive. The inequality reverses itself. A minus times a minus is a positive. A minus times a minus 3 is a positive 3. My domain has to be values of x that are bigger than or equal to 3. If I put 3 in there, 3 minus 3 is 0. I'm sorry, less than or equal to 3. If I put something less than 3, if I put 2 in here, 2 is less than 3. 3 minus 2 is 1. Square root of 1 is 1. If I put 0 in, no problem. If I put something that's bigger than 3, like 4, I get 3 subtract 4. You can't do that. 3 subtract 4 would be a negative value. I'd be taking the square root of something negative. It would be imaginary. All right. The radicand in a radical, a function that has a radical, has to be, this radicand has to be bigger than or always equal to 0. So I just solved it and found out that x had to be less than or equal to 3. And number 31, we see it's letter B. Composite, one function goes into another function. So f of x is equal to 6x plus 13. G of x is 3x minus 1. So I want the composition. I know that's because it's a open circle, it's not times. So it's f of g of x. So it's f of the g function is 3x minus 1. So wherever I see x in the f function, I'm going to make the substitution. So in the f function here, I've got f of, it would be 6 times x, but my input is the g function. 6 times x, or 6 times 3x minus 1 plus 13. So I got 18x, let's see, minus 6 plus 13. This looks like 18x plus 7. 18x plus 7. I like that. 32, letter A. That's pretty simple. Composite functions. One function goes into another. And it's just the way you see it. F composite G. F composite G. F of G of x. There's my G of x. I put this value into my x function, into my x variable in my f function, and do my thing. Multiply by 6 and add 13. Uh, 33, I probably will, I'll graph that. I'll do that separately using my calculator. I'll just mark that down, 33. I'll do it on my calculator, but You know what the basic absolute value function looks like. Alright. The plus 3 would mean I move it in the opposite direction. I move it 3 units to the left, and the 4 mean I move it up 4 units. So you could see it'd be letter A, but I'll graph that, but it's easy enough to figure out what's going on. 35. Well, here again, I would do 35. I would graph it, and I would show you which, we could replace y with negative y and x with negative x. If I replace x with negative x, I get back the same equation. Placing x with negative x and the equation stays the same. We know it's got y-axis symmetry. This is what, number 35. Alright. If we remember it from symmetry, we know by substituting x with negative x, I get back the same equation, y-axis, but here again, I'll graph that one. 36, yeah, it gives me the graph. It gives me 4 potential equations. This guy's moving all around on me. Well, first of all, this is a linear function, right? It has a y-intercept of -1. Well, this is not a line. All of these look like the basic square root function. But what's happened here, this guy has moved 1 to the right. You'd think that would translate to a positive 1. Actually, it translates to a -1. So if you didn't remember that, how these guys work as far as the number that's associated or in the radical, the -1 actually moves it to the right in the opposite direction. What you would do here is that you'd have to graph all four of these. You probably would not do that because it's a line. Graph these 3 and found out which picture matched the picture that you got here. But the -1 moves the basic parabola. This is the basic parabola here. Y is equal, not parabola, square root function. Y equals the square root of x. And the -1 moves it to the right. A +1 would move it to the left. So 36, you can get around it without having to graph. Number 37. You know what the basic parabola looks like, okay? You know what y equals x squared looks like. Now you see what's going on here. When you got a coefficient that's between 0 and 1, it compresses it. It doesn't stretch it. If this was like a 4 or 5, it would stretch it. It would make it longer and thinner. Since this coefficient is between 0 and 1, it compresses it. It makes it fatter. And the one that's fatter, well, we knew it wasn't this guy here because this is going downhill. It's going down. This is going down. So this guy here would be something like this. It would be f of x equal to 6x squared. The 6 would make this guy longer and thinner. But because it's a fraction, it squishes the original parabola, compresses it, makes it wider. Alright, letter A. And once again, if you didn't realize that, you would just graph that and match it up. You knew it wouldn't look like B or D, and it wouldn't look like C because it'd be wider. Alright, it's compressed. But you could graph it and find out which one it was. Here, the -3. Your basic cube function looks like this. Alright, going through the origin. The -3, you would think, moves it to the left. It actually moves it to the right, and then the +1 moves it up 1. Number 38. Alright, so the -3. Alright, the one that's been moved, both these guys have been moved to the right, but 3, but the +1 means this guy goes up 1, so the one that goes up 1 is this guy here, but here again I would suggest you just graph that. Alright, instead of trying to play games, just graph that with your calculator and you'll see that the only picture that looks, the only one that looks like it is letter C. Alright, these guys, the other 3 graphs don't look anything like that, so you could graph this on your calculator. No big deal. Not a big deal. 39, find the vertex. Well, the vertex of a parabola, if I slide this up, the vertex of a parabola is minus b over 2a, comma, f of minus b over 2a. So what's my a value? My a value is 6, and my b value is minus 12. So the opposite of b over twice a, the opposite of minus 12 is positive 12 over twice a. If a is 6, twice 6 is 12. So my x value of my vertex is 12 over 12, or 1. There's only one that has the right guy right here. Now if I were to put 1 back into this function, 6 times 1 squared is 6, minus 12 is minus 6 minus 1 will give you a minus 7. But the minute I knew that my x value of my vertex was 1, this is the only one that had, this guy had negative 2, that had negative 1, this had 2. It was the only one, so I was basically finished. Alright, I'm going to stop there, and then I'll do, I got a couple to do, 32, 33, 34, 35 on the calculator, and then I'll finish up 40 through 57 or 58 on another video. Okay.